So, good morning. So, I will present about carbon-based sulfonated catalyst as an environment-friendly material. This is a mini review for the carbon-based sulfonated catalyst. My name is Putu Patmarekadiandra from Universitas Katolik Parahyangan. The agenda of this presentation is there is a 4-point. The first of all is introduction, and then method of synthesis catalyst. There is an existing method, advantage of this and disadvantage, and the recent research. And followed by application of carbon catalyst and limited interaction using sulfonated catalyst. And we jump to conclusion for further research based on review. So the introduction first. The chemical industries right now is is developed rapidly, but in the same time, some regulations are emerging to make the technologies more sustainable and more green. So there is a challenge in the chemical industry in the future. The one technology that important in the chemical industries is catalyst. The catalyst itself have a huge diversity of type, phase, and then it resources, the support, and etc. But the problem is this catalyst itself is sometimes dangerous for the environment, and then corrosive, harmful, toxic, highly flammable, and something else. And the second problem is not sustainable, because we see from the environment is sometimes dangerous, and when we see the economic is expensive. So how to change this with the changing material? We can solve this problem with the changing material of catalyst. We will briefly introduce the acid catalyst. Why we use acid catalyst? Because of because there is a huge many reactions using acid catalyst as acid catalyst for a better selectivity or conversion, or even a faster reaction rate. Acid catalyst is divided into two groups. There is a homogeneous phase and a heterogeneous phase. So for the example, the homogeneous is sulfuric acid, hydrochloric fluoride, hydrogen fluoride, or aluminum chloride. The conversion and selectivity in the homogeneous phase is excellent, but is harmful and corrosive. So research in the recent years favorably move into the heterogeneous phase. The heterogeneous phase itself, there is a catalyst that is commercial to use in a reaction, for the example, Amberlis or Nafion. They have a unique characteristic. It's not toxic and it's not corrosive and have a greater acidity. But the problem is it's expensive. This is an expensive material, and sometimes it's unstable. So what the solution of this problem? We can use a carbon-based catalyst. And why we use a carbon-based catalyst is because it's abundant in nature, and then stability of structure, and easy to separate. So this is a good requirement for the catalyst in the industry. And where we can find the carbon resource, we can find in the starch, we can find in lignin or cellulose or hemicellulose, and we can find in polysaccharides or disaccharide, or even in the saccharide, or even in a waste that contain carbon. So the objective of this mini review, is about the current synthesis process, application of sulfonated catalyst, and the further research for conclusion. We will jump into method of synthesis catalyst. The current synthesis itself is divided into 6 groups. There is a pyrolysis, hydrothermal, and the carbon mesoporosilica support, specialized sulfonating agent, direct synthesis, and then grafting method. With the different, each of this method have a subgroup. We first jump into pyrolysis method. The pyrolysis method itself will be held at 250 degrees Celsius until 650 degrees Celsius. It's a carbonization step. We'll be forming a polycyclic aromatic compound. Because of dissociation of COC bonds, the pores of material will increase because of high temperature, and the sulfonated group will be bound into polycyclic aromatic structure. This pyrolysis method divided into two type, and this is a modification, is called impregnation. If we don't use impregnation, there is no chemical activation, so the result will be a lower surface area. But if we use impregnation, there is a chemical activation. Using a reagent, for the example, zinc chloride, phosphoric acid, or chloric acid, the result of catalyst will be have a larger surface area but have a lower acid density. So this is a disadvantage of using this impregnation. This is a simple mechanism. The carbon precursor will be pyrolyzed and forming a polycyclic aromatic compound, and this compound will be sulfonated, and we can get the sulfonated catalyst. And if we use the impregnation process, the carbon precursor will be activated with the chemical first, and then with the same method as before, and we can get the sulfonated catalyst. The advantage and disadvantage is high activity catalyst obtained and the larger surface area if we use the impregnation process. But the problem is easy to leach at high temperature process, so sometimes it's unstable. As we can know that the zinc chloride is harmful to environment, we need more utility because of high energy that used for the carbonization because of high temperature, long time process, because this process can in some research can be done in 12 hours or sometimes it's 24 hours, and then low acid density if we use the impregnation process. This is an example of catalyst that synthesized with the pyrolysis and sulfonation method. This is a continue to hydrothermal method. The difference between the pyrolysis and this method is a carbonization, and it held at 180 degrees Celsius until 250 degrees Celsius, forming hydrochar. For this carbonization, there is a mechanism called the Grotthuss mechanism, and if we sulfonate, it will be same. The sulfonic group will be bound into hydrochar. This is a hydrothermal sulfonation called the Grotthuss mechanism. As we can see, this is a glucose as a precursor, will be hydrothermal, and will be occurred a dehydration reaction, forming a hydrochar, and will be sulfonated and get some sulfonated hydrochar and as a catalyst. The advantage using these two stages of hydrothermal sulfonation is more mild condition, no organic solvent or surfactant, less CO2 emission, and no more nitrogen to use. But the problem is this is a two-stage method, so it's less efficient and a long time process. Sometimes it can be done in the 39 hours, so this is very not efficient way to make a catalyst, especially for industry. The modification itself is simultaneous hydrothermal sulfonation. The principle is same, but the hydrothermal sulfonation method will be held in just one equipment, so we can get the sulfonated catalyst. The advantage is more mild basically same like a previous method, but the point is we have an efficient on economic side because just need one equipment to do this. The problem is the few groups then that can attach in carbon structure, which means that if we need another groups except sulfonate group, it will be problem in the reaction and lower surface area than pyrolysis. This is an example of reaction that have been studied in the past, and this is simultaneous hydrothermal sulfonation method. We continue to sulfonation from PAC. PAC is a polycyclic aromatic compound. Is from the example is naphthalene, will be sulfonated directly. This is a simple mechanism of this method, and we can get the sulfonated catalyst in the right. The advantage and disadvantage is actually similar to pyrolysis method because the polycyclic aromatic compound can be found if we use a carbonization, at the pyrolysis temperature. So the advantage and disadvantage will be similar to pyrolysis method. And there is a direct sulfonation method to make a catalyst. The carbon precursor itself will be sulfonated directly with non-degradative reagent. And for the example, the starch molecule will be reacted with the chlorosulfonic acid. With the non-degradative reagent is in this example is chlorophyll. At 0 degrees Celsius, we can get a sulfonated catalyst, and some gas that released into environment is this is chloric acid gas. Yeah, we can see this is an easy way to do to make a catalyst, but this use a harmful reagent, is not thermal resistant, and few study to use this method for making a catalyst. So there is no surface area that occur acid density or another characteristic for the catalyst. And then we continue the grafting method. The grafting method itself is carbon precursors will be modified to increase some characteristic with the grafting method. So the first of all, we need to sulfonate the carbon precursor itself, and then graft it with a different monomer or polymer, and then we got some catalyst that grafted with this monomer. Don't need carbonization step. This is same like a direct sulfonation. So reduced utility. Right now it's still in research, so we need to know more if we use a grafting method. And the preliminary result is catalyst itself will be degraded more than 200 degrees Celsius. So this catalyst is not suitable to use in a high temperature process. The mechanism itself is especially did in a grafting method. The starch molecule and acrylic acid will be make it to be have a free radical ion with the radiation or ammonium persulfate, and then we will get the starch graft copolymer. And then special sulfonated agent. This is a sulfonating method that uses a special agent like this in the slide. This is the first one. This is the second one. The advantage is a medium temperature, simple and easy to separate, but is expensive and difficult to find its raw material. The last one is carbon or mesoporous silica-based support using silicon template, and then the result have a high acid density, and the density decrease as the surface area decrease. It can be found that high conversion of reaction than sulfonated mesoporous carbon, but the disadvantage is need to remove silica from catalyst to prepare mesoporous carbon. So this is not sustainable because we use silica, and then the silica itself will be a waste in the next step. So it's not sustainable. The application of catalyst. First of all, it comes from biodiesel production. Biodiesel itself is a green technology, of course. This is green fuel that we need to use in the future. The biodiesel itself have a toxic, non-toxic characteristic. There is no sulfur that release into environment, and then there is a less CO2 or even carbon monoxide emission to environment. And where we can find this, where we can produce this biodiesel. For the example, we can get it from the palm oil. The mechanism itself to make a biodiesel, there is a two reaction, transesterification and esterification, using a base catalyst and the acid catalyst. And one research, it found that these two reactions can be done in a simultaneously way if we if using one catalyst is called an acid catalyst. We use this acid catalyst. Why? because we know that if we use a base catalyst in reaction 2, there will be a saponification, so it's hard to separate. But if we use acid catalyst in reaction 1, the reaction will be slower and need a high temperature process. So the acid catalyst itself will be the answer for this simultaneous way. But of course, there is need a modification first. So the reaction 1 will be held at the faster time. This is the example of carbon-based sulfonated catalyst for biodiesel production, as we can see with those conversion, selectivity, and yield. We continue to hydrolysis. Hydrolysis itself is convert high molecule. For the example, polysaccharide, disaccharide into small molecules. For the example, for this mechanism is sucrose will be hydrolyzed with water. The water itself will form a glucose and fructose as a small molecules. This is the example of reaction that use acid carbon-based sulfonated catalyst that used in the hydrolysis with its conversion, yield, and selectivity with the different method of hydrolysis and the catalyst type and method to make this catalyst. Because of this acid catalyst have a different application in many reactions, so we will discuss this reaction briefly in the next slide. So first of all, there is a synthesis ethylevulinate, and then acetylation, and then Michael type Friedel-Crafts, and then the dimerization alpha methylstyrene in this. So the acid catalyst itself have a great amount of reaction that use acid catalyst for the process. We jump into the conclusion. It can be found that carbon catalyst itself is realizing greener and sustainable technologies, and the carbon catalyst itself generally have a better result than the commercial catalyst. And right now, hydrothermal and one-step sulfonation more favorable to be researched in the future because hydrothermal itself have a lower utility needs than pyrolysis method, and one-step sulfonation is easiest way to make a acid catalyst. But the problem is using hazardous solvent or agent sometimes have a long time process and a non-optimal operation. So this is a problem if we use a hydrothermal and one-step sulfonation. So there is need an improvement to change this, of course, using hazardous solvent or agent for the sustainable process or a greener process. The improvement in the catalyst, of course, we need to do that, like a conversion, selectivity, parameter of catalyst, especially in mechanic, because of the mechanic itself is important because this catalyst need to be done in the industrial scale. And the characteristic for this catalyst itself, for the example, like the acid density and the acid density and the surface area or porosity and another characteristic parameter. And of course, need to improve the sustainability, especially in the process of making this catalyst. So how to be done to improvement this is a new process or modified process and the economic design. The modified process itself is I think it's more easier than we need to find the new process, because if we use a modified process, we can answer this challenge. For the example, change the solvent or agent or have a optimum process operation. And if you use economic design, it will be we need to know that this process will be feasible if run into industrial scale. So thank you for your attention. sorry if there were words that were not pleasing, of course, and suggestion and input will be very meaningful and open for discussion.
Good day. Thank you for this great opportunity. On this beautiful day, it is an honor for me to present our research at this conference organized by University of Surabaya. First, let me introduce myself. My name is Felix Ariel Simbara Barus. I am from Indonesia and I would like to share about how energy efficiency, smart factory and mass personalization affect companies in Industry 4.0. The first author is Professor Shaw, the second is me, and the third is Dr. White. First, the introduction section. It will beginning with the research background. Phenomena which appear in the real world, especially in the industry environment, and arise from the rapid development of technology have framed a new form of concept called the fourth generation of industrial revolution. This concept is commonly known as Industry 4.0 by scientists, governments, and industrial practitioners. The term Industry 4.0 has created new changes that must be managed to positively affect both business and society. Moreover, the concept itself will provide many scientific variations that can be developed in the industrial era of 4.0. For that reason, energy efficiency improvement, smart factory, mass personalization, and organizational performance were taken as the research indicators. Next, it is about the research question. How should the manufacturing manager consider Industry 4.0 indicators, especially the effect of energy efficiency improvement, smart factory, and mass personalization on organizational performance? And then, the research objective is to summarize the information on the industrial environment industry to perform for general modeling based on the construction's industrial practitioners' perceptions. Lastly, in regard to the research contribution, the study proposes an initial model in the role of Industry 4.0 to examine the OP by exploring the relationship among EEI, SF, and MP. In the framework and methodology section, first, this is a purpose research framework and hypothesis. H1, EEI positively influence MP. H2, EEI positively influence OP. H3, SF positively influence EEI. H4, SF positively influence MP. H5, SF positively influence OP. And finally, H6, MP positively influence OP. In the research methodology, we use a partial least square sectoral equation model, in short called PLS-SEM. In the sampling technique, a Likert scale survey with 5-point degree of agreements, ranging from strongly disagree to strongly agree, was applied to evaluate the research model. The questionnaire contained 25 questions. EEI are 11, SF are 7, MP are 3, and OP are 4 items. In the data collection part, the data were taken from 100 workers in the several companies around Taipei City, Taiwan, and no data were missing. All participants were Taiwanese who were used to digital technologies in their daily routines and had similar background in manufacturing. Majority of the participants had master degree, were males aged 41 to 50, were from large enterprises or company with more than 251 employees, and with gender over 20 years. In the research sections, table 1 shows that the square root of API was higher than the correlation of its structure. Thus, this framework surpasses the discriminant validity test. Table 2 illustrates that the results show the compound alpha for each dimension was greater than 0.7. The CR values were all greater than 0.7. And finally, all API numbers were higher than 0.5. So, it can be concluded the model was surpasses the reliability test. Table 3 describe the R square of OP 59.1% reflected moderate. Further, GOF index in this research was 0.637, which surpasses the cut-off value of 0.25 for medium effects of R square. And finally, all items fulfill the minimum standard of item logic criterion, more than 0.7. The hypothesis testing and conclusion section. In this section, we can see that the research indicated the significant influence on organization performance in 5 cases from H2 to H6 except X1. The findings show that energy efficient improvement, smart factory, and mass personalization effects to the organizational performance simultaneously. The findings also show that mass personalization cannot be put as a standalone indicator without considering the influence between smart factory and energy efficient improvement to measure the organizational performance. Finally, the experimental results support to the suggested research framework and hypothesis in medium level categorical. Thank you for listening.
Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu Om, Namo Buddhaya, greetings of kindness. Thank you for the opportunity being given to present our research article. Information and communication technology have enabled all of us to participate in online conference. I am Dr. Restana Faradimarta, or familiar being called Frat, as the third author after my two research colleagues, Mr. Yoni Kristiawan and Dr. Edi Purwanto. The title of our research is The Role of Supply Chain Performance Factors to Determine the Firm Performance. Economy development in Indonesia intensifies companies' competition in the market. Continuous availability of product is an essential factor to improve competitiveness. Coordination between supply chain and retail company is required to achieve this purpose. Investigating the mediating role of Alfamart's supply chain performance. This research is conducted to Alfamart branch offices and distribution centers in West Java as one of the provinces with highest modern retail sales growth when compared to the province others on the island of Java. The following are research questions. The first is, how is supply chain management performance, or we abbreviated with SCM, impact firm performance? The second research question is, how is customer relationship management influence SCM performance? The third is how is information sharing influence SCM performance? The fourth is how is supplier relationship management influence SCM performance? The fifth is how is the mediating effect of SCM performance on the relationship between customer relationship management and firm performance? The sixth, how is the mediating effect of SCM performance on the relationship between information sharing and firm performance? The seventh, or the last one, how mediating impact of SCM performance on the relationship between supplier relationship management and firm performance. And goes to literature review. The first is supply chain management performance affect firm performance. Indicators that will be used to describe the company's performance variable are income, profit, customer loyalty, product quality, service speed, inventory turnover, and customer relations. And then the second one about customer relationships management influences supply chain management performance. Customer relationships management means building long-term relationships with customers by responding quickly and managing customer complaints and finding ways to improve overall customer satisfaction. The third one about information sharing affects supply chain management performance, or we abbreviate it with SCP. Information sharing in the supply chain is very important to ensure the smooth flow of information, in which the smooth flow of information is important to ensure the improvement of SCP itself. And the last one about supplier relationship management, or we abbreviate it with SRM, influences supply chain management performance. Effective implementation of SRM is important and is believed to have a significant impact on many processes in a retail company. For example, related to planning and implementation, resource analysis, supplier, performance monitoring, and supplier collaboration. Here with the feature about the relationship between the variable on our research. The research methodology of this research, we begin from the population, Alfamart's branch offices and distributor centers in West Java, as mentioned before from my presentation. We conclude we involving 288 coordinators. The study employs random cluster sampling and determines the sample size with Slovin's formula, which produced a number of 168 samples. The instruments consist with 5 customer relationship management, 3 information sharing, 3 supplier relationship management, 6 supply chain management performance, and 3 firm performance. Based on the result of the following regression test, there are several numbers that show estimates compared to the p-value threshold points of 0.05. The first is about SCM performance. Effect firm performance with estimate point is 0.662, which means supported because it is above the 0.05 p-value figure. And then the CRM effect SCM performance with estimate point is 0.541, which means supported because it is above the 0.05 p-value. And the third, information sharing doesn't affect SCM performance with estimate point is 0.011, which means rejected because it is below the p-value. And the last one, SRM effect SCM performance with estimate point is 0.554, which means supported because it is above the p-value. Based on the result of the following Sobel test, to know the mediating effect, there are several numbers that show estimate compared to the p-value threshold point of 0.05 again. And CRM to SCM performance estimates 0.541 and SCM performance to firm performance estimates 0.662. It means supported. The calculation result is the p-value of the indirect effect is 2.783 and the p-value is 0.005. So the fifth hypothesis is supported. And information sharing to SCM performance estimates 0.011 and SCM performance to firm performance estimates 0.662. So the calculation result is the p-value of the direct effect is 0.112 and the p-value is 0.910. So the sixth hypothesis is rejected. And the last, about the mediating effect, we begin with supplier relationship to SCM performance estimates 0.554 and SCM performance to firm performance estimates 0.662. The calculation result is the p-value of the indirect effect is 2.626 and the p-value is 0.008. So the seventh hypothesis is supported. The square multiple correlation, we found the following research findings. The first, about the determination coefficient between customer relationship management, information sharing, and supplier relationship management for SCM performance is 0.687 or 68.7%. It indicates the number of influence from CRM, information sharing, and SRM on SCM performance. And the second, about the coefficient of determination between SCM performance against firm performance is 0.430 or 43%. It indicates the number of influence from SCM performance on firm performance, while the remaining 57% is influenced by other variables outside the research model, such as competitive advantage. And we come to the conclusion of my presentation. The study finds that most hypotheses are supported and 2 hypotheses are rejected. The first hypothesis is SCM performance effect firm performance significantly. The second and the fourth hypothesis are SCM performance is influenced by customer relationship management and supplier relationship management. And the third hypothesis is information sharing does not effect on increasing the influence of customer relationship management on company performance. The sixth hypothesis, SCM performance does not mediate the effect of information sharing of company performance. The third hypothesis is information sharing does not affect SCM performance. The fifth hypothesis is SCM performance has an indirect effect on increasing the influence of customer relationship management on company performance. And the sixth hypothesis, SCM performance does not mediate the effect of information sharing on company performance. And the last one, the seventh hypothesis, SCM performance provides an indirect role in increasing the influence of supplier relationship management on firm performance. That's all for our presentation. Thank you for your attention. Here are some of my social media contacts and emails that are possible for colleagues who wish to carry out research collaboration with related fields or research methodologies that I presented earlier. Wabillahi taufiq wa hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Greetings and welfare.